Hi there, welcome to edupediaworld.com. You are watching the videos on number system. So in this video we'll discuss operations on real numbers, how to solve real numbers. Then we'll discuss some of the rules that can be applied to solve real numbers. Then we'll discuss geometrical representation of real numbers. Then we will discuss how to rationalize real numbers, which is very important concept. You have to watch this part very carefully. Then at the end of the video we'll discuss some of the advanced questions and concepts which are generally seen in examination. So we follow same step, same procedure and same strategy to explain each and every concept through solving example. So let's get started with our first concept, which is rules on solving real numbers. Okay. Now in this rules on real numbers we'll discuss each and every rule, and we'll try to solve some of the basic examples related to these rules. So the first rule is under root of AB equals to under root of A into under root of B. This means suppose we have under root of 6, so it can be written as under root of 2 into 3. So this means this can also be written as under root of 2 into under root of 3. Okay, now this was the first rule. Now the second rule is under root of A upon B can be written as under root of A by under root of B. So this means suppose we have under root of 7 upon 5. This means it can be written as under root of 7 upon under root of 5. So let's move off to further rules. So the next rules are, now the third rule is under root of A plus under root of B into under root of A minus under root of B equals to A minus B. Now we have already seen identity in polynomial that A plus B into A minus B equals to A square minus B square. So we can apply the same identity to this rule. So let's see an example. Suppose we have under root of 5 plus under root of 3 into under root of 5 minus under root of 3. So we have to solve this question. So we can clearly see that we can apply the identity. So this can be written as under root of 5 whole square minus under root of 3 whole square. Why? Suppose if we compare this part with the identity A plus B into A minus B, here A will come out to be under root 5 and B will come out to be under root 3. So this means this can be written as under root of 5 square minus under root of 3 square. Now let's see how to solve this part. Now under root of 5 can be written as 5 raised to power 1 by 2. So this means under root of 5 square can be written as under root of 5 whole square can be written as 5 raised to power 1 by 2 whole square. So this comes out to be 5 raised to power 1 by 2 into 2. So this and this get cancelled. So answer will come out to be 5. Okay. Now this means this can be written as 5 minus 3. So the answer will come out to be 2. So that's why under root of A plus under root of B into under root of A minus under root of B is A minus B. So let's discuss the fourth rule. Fourth rule is A plus under root of B into A minus under root of B can be written as A square minus B. Again we can apply the same identity in this part also. So let's see the solution of this rule to an example. Suppose we have 5 plus under root of 3 into 5 minus under root of 3. This means it can be written as 5 whole square minus under root of 3 whole square. Why? Because this becomes a plus b into a minus b, where a is 5 and b is under root 3. So we can apply this identity over here. So the answer will come out to be 5 square is 25, and we have already discussed under root of any number square will always be equal to its number. So the answer will be 3. So 25 minus 3 is 22. So this is the solution. So let's discuss next rules to solve the number systems. Okay. Now the next rule is under root of a plus under root of b into under root of c plus under root of d equals to under root of ac plus under root of ad plus under root of bc plus under root of bd. So let's discuss this rule. The rule is under root of a plus under root of b into under root of c plus under root of d equals to under root of ac plus under root of ad plus under root of bc plus under root of bd. So let's solve this solution. So what we can do over here is we can do bracket multiplication. So the thing is, it will come out to be under root of a into under root of c plus under root of d plus under root of b into under root of c plus under root of d. So the answer will come out to be under root of a into under root c is under root ac plus under root ad plus under root bc plus under root bd. So this is the solution of the rule. Now so let's discuss example related to this. Suppose we have under root of 3 plus under root 2 into under root 5 plus under root 4. So we can clearly apply this rule in this example. So our a will become under root 3, b will become under root 2, c will become under root 5, d will become under root 4. So we can directly apply the solution. So the answer will come out to be under root of 3 into 5 plus 3 into 4 plus then b into c. So it will be 2 into 5 plus b is 2 into 4. So the final answer will be under root 15 plus under root 12 plus under root 10 plus under root 8. So this is how we can apply the rules. So let's discuss another rule, which is under root of a plus under root of b whole square equals to a plus 2 under root ab plus b. Now we can clearly see that we can apply identities as we discussed in the polynomial. The identity is a plus b whole square equals to a square plus b square plus 2ab. So we can directly apply the identity. Over here a will become under root a and b will become under root b. So the solution will come out to be under root of a plus under root of b whole square will be under root a square plus under root b square plus 2 into under root a into under root b. So the answer will be under root a square will be a plus under root b square will be b plus 2 under root a into under root b will be under root ab. So this is the final solution. So let's discuss with an example. Suppose we have to solve under root 3 plus under root 2 whole square. So over here a will become under root 3 and b will become under root 2. So we can directly apply the rule. The rule will be a plus b plus 2 into under root ab. So the answer will come out to be 3 plus 2 plus 2 under root 3 into 2. So the answer is 5 plus 2 under root 6. So this is the final solution. So let's discuss further example related to these rules. So these are some of the basic examples, so which some of them are we have already discussed. So let's do the examples quickly. So the first question is, we have to solve 5 plus under root 7 into 2 plus under root 5. So we can apply rules or we can apply bracket multiplication. So whenever you cannot apply any kind of identity, so it's better to always do bracket multiplication. So what we can do is we can apply bracket multiplication like this: 5 into 2 plus under root 5 plus under root 7 into 2 plus under root 5. So the answer will come out to be 5 into 2 is 10 plus 5 into under root 5 is 5 under root 5 plus under root 7 into 2 is 2 under root 7 plus under root 7 into under root 5 is under root 35. So what we can do further is, so there is no like terms, so we cannot add or subtract any terms. So this is our final solution. So let's discuss next question, which is 5 plus under root 5 into 5 minus under root 5. So in this question we can clearly see that we can apply one identity that we have discussed in polynomials. The identity is a plus b into a minus b, which is a square minus b square. So over here we have a as 5 and b as under root 5. So this means 5 plus under root 5 into 5 minus under root 5 can be written as 5 square minus under root 5 square. So the answer will be 5 square is 25 minus under root 5 square is 5. So the answer is 20. Now let's discuss the third question. Now the third question is, we have to find under root 3 plus under root 7 whole square. So we can apply the identity a plus b whole square, which is a square plus b square plus 2ab. Now the a in this question is under root 3 and b in this question is under root 7. So this means under root 3 plus under root 7 whole square can be written as under root 3 square plus under root 7 square plus 2 into under root 3 into under root 7. So this comes out to be under root 3 square is 3 plus under root 7 square is 7 plus 2 into under root 3 into under root 7 will be 3 into 7. So it will be 10 plus 2 under root 21. So this is the final solution. So let's discuss the fourth question. The fourth question is, we are given with we have to solve under root. The fourth question is under root 11 minus under root 7 into under root 11 plus under root 7. So in this question we can again apply the identity, which is a plus b into a minus b, which is equals to a square minus b square. So a over here is under root 11 and b is under root 7. So this comes out to be under root 11 square minus under root 7 square. So this comes out to be 11 minus 7, which is 4. So this is how we can apply some of the rules of real numbers. Now next we'll discuss geometrical representation of real numbers. So there are certain steps and rules to follow how we can represent any real number on paper or graph paper. So let's discuss the rule. So first step is, suppose we have to find the under root of 3.5 geometrically on a graph paper. So the number can be any, it can be 4.3, it can be 2.7, 3.8. So it doesn't matter, the rule applies same to all the numbers. So suppose here we are given 3.5. What we have to do is we have to draw a straight line of 3.5 centimeter, any units. Then the next step is we have to draw line of 3.5 units. So next step is we have to extend this line by 1 unit. Means suppose we have drawn line of 3.5, then we'll draw 1 unit line more. So the final line will come out to be 4.5, and here we will mark 1 centimeter, let it be B, and let it be A, and let it be C. Then this line is 3.5 and the total line is 4.5. Now what we have to do is we have to take a middle point of AC. Then we have to take midpoint of AC, means we have to take a midpoint of this line AC. How we can take? What we'll do is we can take it with a compass, like we will find the midpoint of the line AC. So what we'll do is we'll open the compass more than half the length of AC. Means we can open the compass till here. Then we will draw perpendicular bisector of line. So means we can draw a perpendicular bisector of a line. Then we'll mark O point as midpoint. Then with O as center we'll draw a semicircle. So then from B we'll draw another perpendicular line. The line touches at this point, like this, at this point at D. This length of a line then is the length of under root 3.5. So this is how we draw the number lines, real numbers on graph paper. So let's discuss further concept. which is rationalization. So now this concept is very important, and these type of questions will definitely come in the exam, so you have to watch this question very carefully. Rationalization means, suppose we are given a number. The number over here is, just give me a moment. Now the number over here is 1 by under root 2, and we can clearly see that this under root 2 part is irrational. So rationalization of denominator means we have to convert this number into rational number, means we have to rationalize the denominator. So how we can do it? Watch carefully. Now we are given 1 by under root 2. If we multiply under root 2 with denominator and under root 2 with numerator, we'll get is under root 2 upon under root 2 into under root 2. So the answer will be under root 2 upon under root 4. So the answer will be under root 2 upon 2. So we can see clearly we have rationalized the denominator. So this is always a first step. Whenever you want to rationalize the denominator, you have to multiply with the same number so that you can rationalize the denominator. Now see this question. The question is, we have to rationalize the denominator again, 1 by 2 plus under root 3. Now if we multiply with suppose we multiply with 2 plus under root 3 into 2 plus under root 3, we can see this will become an identity a plus b whole square, but this will not rationalize the denominator. Why? Because on solving this identity, again the irrational numbers will come. So what we have to do is, we have to take opposite sign of this number, means the number is 1 by 2 plus under root 3, then we have to multiply the denominator with 2 minus under root 3 and with the numerator also. Why with numerator? Because it will cancel out and the number remains the same, so there will be no change in the number. So the number becomes 2 minus under root 3 upon, now this becomes the identity a plus b into a minus b. So this can be written as 2 square minus under root 3 square. So the answer will come out to be 2 minus under root 3 upon 2 square is 4. So 4 minus under root 3 square is 3. So it is 4 minus 3. So the answer is 2 minus root 3 upon 1. So this is rationalization of denominator. Okay. Now we have next question. The next question is, we have to rationalize the denominator of this number. So the number is 5 upon under root 3 minus under root 5. So we can write this as 5 upon under root 3 minus under root 5. So for rationalization, what we have to do is, we have to multiply with the same number but with opposite sign. So we multiply this with under root 3 plus under root 5 and with the numerator also. So we get is 5 into under root 3 plus under root 5 upon, now this becomes identity which is a minus b into a plus b. So this comes out to be under root 3 whole square minus under root 5 whole square. So this comes out to be 5 into under root 3 plus under root 5 upon 3 minus 5. So the answer is 5 into under root 3 plus under root 5 upon minus 2. So this is the final answer. So let's discuss some of the advanced question on rationalization or on a number system. So the first question is, we have to express 0.6 plus 0.7 bar plus 0.47 bar in the form of P by Q. So watch this question very carefully because it's very interesting question. So we have 0.6 plus 0.7 bar plus 0.47 bar. Now what we have to do in this question is we have to add this question. So for addition we can write 0.6 as 0.6 and 0.7 can be written as 0.77777 and it will continue, and 0.47 can be written as 0.477777 and it will continue. So we have to add the questions, so we'll add it. So 7 plus 7 is 14, 1 carry, then 15, again 15, 15, 15, 1 carry, then again 1 carries on. So what we get is 6 plus 4 10, 10 plus 7 17 plus 1 18, so 0.1. So the final number is 1.8555. It will continue on. So the final number we got is 1.85 bar. Now we have to represent this number in the form of B by Q. So what we say is let x equals to 1.85555 and it will continue on. Now we have bar upon one number, so we'll multiply with only 10 on the both sides. So what we get is we'll get 18.5555, and then what we do is we subtract 1 from 2. We get is 9x equals to 18.5555 minus 1.8555. So the answer is, this will cancel out, this is 5, 1 will carry, so the answer will be 15 minus 8 is 7, minus we'll get is 7 over here. So 7 minus 1 is 6 and 1, which is equals to 9x. So we got 9x as 16.7. So x is 16.7 upon 9. So the answer is 167 upon 10. So this is which is P by Q form. Okay. Now let's discuss the next question. Okay, the question is, if a equals to 3 plus under root 5 upon 2, then we have to find the value of a square plus 1 by a square. So watch this question carefully. We know that a plus 1 by a whole square, we can apply the identity a plus b whole square. So which is a square plus b square. B square over here is 1 by a plus 2 into a into b. So b is here is 1 by a. So what we get is a square plus 1 by a square plus 2. Why? Because this and this will get cancelled. So we have a as 3 plus under root 5 upon 2. So what we can do is we can put the values over here. So we got 3 plus under root 5 upon 2 plus 1 by a means we have to write 2 upon 3 plus under root 5 whole square, which is equals to a square plus 1 by a square plus 2. Now what we have to do is we have to take LCM over here. So LCM is 2 into 3 plus under root 5. So here it comes out to be 3 plus under root 5 whole square plus here it will come out to be 2 square upon whole square, which is equals to a square plus 1 by a square plus 2. Now we'll solve this bracket. So it is a plus b whole square, so it will be 3 square plus under root 5 whole square plus 2 into 3 into under root 5 plus 2 square is 4 upon 2 into 3 plus under root 5. So it will come out to be whole square, which is equals to a square plus 1 by a square plus 2. So what we can do further is, so 3 square is 9 plus under root 5 square is 5 plus 2 into 3 into under root 5 is 6 under root 5 plus 4 upon 2 into 3 plus under root 5 whole square. So which can be written as a square plus 1 by a square plus 2. So this comes out to be 9 plus 5 14, 14 plus 4 is 18 plus 6 under root 5 upon 2 into 3 plus under root 5 whole square, which is equals to a square plus 1 by a square plus 2. Now what we can do is we can take 6 common out, so we are left with 6 common out, we are left with 3 plus under root 5 upon 2 into 3 plus under root 5 whole square, which is equals to a square plus 1 by a square plus 2. So this and this will get cancelled, and 2 1s are 2, 3s are, so we can write it as 3 square equals to a square plus 1 by a square plus 2. So 3 square is 9, which is equals to a square plus 1 by a square plus 2. So we can shift the 2 over here, so we get is, what we get is a square plus 1 by a square equals to 9 minus 2, which is equals to 7. So this is the final answer. So let's discuss one more question related to this concept only. Now the question is, we have a as 5 plus 2 under root 6 and b is given as 1 by a. So we have to find the value of a square plus b square. So this implies is we can write a square plus b square as a square plus 1 by a square. Why? Because b is given as 1 by a. So we apply the same identity. The identity is a plus 1 by a whole square equals to a square plus 1 by a square plus 2. So we can write a as 5 plus 2 under root 6 plus 1 by 5 plus 2 under root 6 whole square equals to a square plus 1 by a square plus 2. Now what we have to do further is we have to take LCM. So LCM is 5 plus 2 under root 6. So here the answer will come out to be 5 plus 2 under root 6 square plus 1 whole square equals to a square plus 1 by a square plus 2. So here it will come out to be, we can apply a plus b whole square, which is 5 square plus 2 under root 6 whole square plus 2 into 5 into 2 under root 6 plus 1 upon 5 plus 2 under root 6 whole square, which can be written as a square plus 1 by a square plus 2. Now this can be further written as 5 square can be written as 25, 2 under root 6 can be written as 4 into 6 plus 2 into 5 into 2 can be written as 20 under root 6 plus 1 upon 5 plus 2 under root 6 then whole square equals to a square plus 1 by a square plus 2. Now this can be written further as 25 plus 6 4s are 24, 24 plus 1 is 50. So the answer will come out to be 50 plus 20 under root 6 upon 5 plus 2 under root 6 whole square equals to a square plus 1 by a square plus 2. Now what we can do is we can take 10 as common out, so the answer will come out to be 10 common out. The answer will come out to be 5 plus 2 under root 6 upon 5 plus 2 under root 6 whole square equals to a square plus 1 by a square plus 2. So this and this will get cancelled, so the answer will come out to be 10 square equals to a square plus 1 by a square plus 2. So the final answer is, this implies is a square plus 1 by a square will be equals to 100 minus 2, which is 98. So this is the final answer. So thank you once again for watching the videos on number system on edupediaworld.com. Have a nice day ahead.